And we'll start with example 1. And this is called a composite shape. It's a fairly simple composite shape, but it's a composite shape nonetheless. And what that means is that it's a shape that's a combination of a few shapes. 2, 3, maybe 10 if you're a bit unlucky. But either way, it's a composite shape, a combination. So I'm going to go through now. I can see that this is in centimetres. I'm going to do some labels. Floating around, I'm going to cross off each line as I go and just try and get all my values on here. I'm given those ones. This is 3. It's the same as the opposite 3. This one is 2. I know that's 2 because it's got that little black stroke through the two of them to recognise the fact they're equal. This one is opposite that 8 centimetres, and I'm assuming there's some right angles and parallel lines here. And of course this side should be equal to the combination of that 2, that 4 and that 2. So this side is equal to 8 also. Now I can go through and calculate first of all my perimeter. Perimeter is equal to 8 plus 8 plus 2 plus 3 plus 4 plus 3 plus 2 plus 8. And if we add all those up, we get 38 centimetres. And of course, it's just centimetres. It's not centimetres squared or cubed or anything like that. And the area can be calculated in many different ways, but I'm going to pick out 2 ways you could calculate the area. The first way I'm going to do is probably the obvious way. And that is that I'm going to just drop a little dotted line down here and here. And I'm going to call this area 1, and this one area 2, and this one area 3. And so the area is equal to area 1 plus area 2 plus area 3, which is equal to 8 times 5 plus area 2, which is 2 times 3 plus 2 times 3, and that is equal to 52 centimetres squared. That's one way. Or the other way, which is actually often more simple, is to look at this, and I'll do this one in light blue, so look at this as one big shape and then take away the area that we don't need to count. So I'm going to write this down as area 1. So I said I'll do this one in blue. Area 1 minus area 2. And area 1 is the big shape, and area 2 is this little bit in here. So that means that area 1 is 8 times 8 minus area 2, which is 4 times 3, and that of course is equal to 52 centimetres squared, as we expected from the last question that we just did. So there's always different ways you can do it, and you just need to slow down and think about where those different ways come from, and often you'll have to break down a composite diagram. So let's have a look at example 2, which similarly has a composite diagram, but it is a little bit more complex. So in this case, we're looking at almost like a capital shaded in C shape, and it's designed using circles. So you can see the application here in any sort of design, particularly computer-based, where you might be printing or 3D printing these types of letters, having an understanding of how to calculate areas of these types of shapes. So what I'm going to do here, and again I have multiple options, but this is how I'm going to approach it, is I'm going to break this down as the big circle and the little circle. And I'm not going to be lazy, I am going to draw these out and put my information on there. So here's my big circle, and it has a radius of 5 centimetres. And here's my little circle, with a radius of 3 centimetres. You see, my circles aren't perfect, but realistically they don't need to be. You're calculating areas here, and you just need to make sure your diagram's good enough that you understand it. Now in blue, I'm going to actually recognise that this circle is not a complete circle. And that angle is 40, which means that this angle here is 320. And it's the same over here. So dropping my lines over here, that angle is 320. So I want to work out the area of the big circle, which is actually a big sector. So it's the remaining component of most of a circle, let's be honest. And then the area of the small circle. And then I'll explain what I'm going to do with that. So the area of the big circle, so we'll call this area 1 again, is equal to pi r squared times by theta, which is 320 over 360. So in this case, That's pi times 5 squared times by 320 over 360. And area 2 is equal to pi r squared times 320 over 360, which in this case is equal to pi times 3 squared times 320 over 360. Now, as you move forward mathematically, you need to realise that you don't have to necessarily calculate each component. I could calculate both of these on my calculator, but it's just not worth the effort because I'm going to do one big calculation at the end. And if I calculate these individual components, I'll probably round them, and then I'll do another calculation with rounded values, and the rounding will become more and more significant. And I really want to avoid that. So I'm going to say the total area now is equal to area 2 minus area 1. So notice that area 2 is the whole shape, as I'm about to outline in orange. And area 1, I'm going to highlight yellow, is this inside section. I want to subtract that yellow bit from the larger shape. And so I'm going to do that subtraction now. And once I've completed that subtraction, which looks a bit like this, pi times 5 squared times 320 over 360 minus pi times 3 squared times 320 over 360, I'll come out with an answer of 44.68 meters squared. So there we have it. Calculating areas and perimeters is really trivial as long as you ensure that you do things appropriately, you break the question down if they're hard, and you follow the formulas. You'll need to know how to substitute into formulas and do some formula rearranging, but other than that, it's just really following rules that are set out for you and interpreting diagrams appropriately. All the best.